All right, let's start making our way through the warm-up. We need to find the volume and the surface area for this object. Let's start with volume. What are the names of the two solids that have been stacked on top of each other here? We have a pyramid, and I would hesitate to use the word cube because while I can see I do have a square base, a cube has all the edges that are congruent. So this one I would call a rectangular prism, but we're going to approach it the same way that we would a cube because a cube is a special type of rectangular prism. So we need to take the volume of the rectangular prism and add that to the volume for the pyramid. How do we find the volume for a prism? Plus the height times the height, my apologies. Area of the base times the height. What about the volume for a pyramid? 1/3 area of the base times the height. Perfect. I just mentioned a moment ago that our rectangular prism has a square base. I can see that because it's 6 inches and 6 inches for my length and my width. How do you find the area of a square? Side squared. So I have side squared here times the height plus 1/3. And then what is the shape of the base of the pyramid? Also a square. So this is 1/3 side squared times the height. And our sides are 6 inches. So 6 squared times the height of my prism. What's the height of the rectangular prism? 3. So 6 squared times 3. Let's pause right there and find the volume of just the rectangular prism there. 108. And now we need the volume of the pyramid. So we have 1/3. How big are the sides of the square of the base for the pyramid? 6. So 1/3 times 6 squared. And now I need the height of the pyramid. Do I have the height of the pyramid? No. What did they give me? What's that 5 then? That's the slant height. Notice it's coming down that lateral face. It might be a little hard to see on your paper, but up here, they've got those dashed lines there. That means this 5 inches is my slant height. But I need this right here. It's going to hit the exact center of that base. It's going to make a right angle when it hits the base. In order to find that using Pythagorean theorem, I'm going to need to know this distance here. How big would this be? 3. Because it is a square base, the center is going to be equidistant from all my sides, so it's going to be half of all of my sides. So 3 inches. So now we'll do Pythagorean theorem to find our height. A squared plus b squared equals c squared. What should go in for c? 5. My slant height is my hypotenuse. Okay, so what do I put in for a and for b? 3 and a, or 3 and x, or I'm going to call it h here. This is my height. We just need a variable in the place of either a or b. All right, so I have h squared plus, what's 3 squared? 9 equals 25. Then we subtract 9 from both sides. What's 25 minus 9? 16. So h squared equals 16. We're going to take a square root of both sides. That'll get rid of the squared on h over on the left. And what is the square root of 16? 4. So my height is 4 inches. All right, so 1/3 times 6 squared times 4 gives us what? One-third times 6 squared times 4. 48. So to get my total volume, we're going to add these two together now. What is 108 plus 48? 156. What kind of units should go with that? Inches cubed, yes. Nicely done. All right, so there's our volume. Next up is surface area. So just like with volume, we're going to need the surface area of the rectangular prism plus the surface area of the pyramid. How do we find surface area for a prism? 2 times the area of the base plus the perimeter times the height. Which of those is the lateral area? PH. Here's my lateral area. How do we find the surface area of a pyramid? Yep, area of the base plus 1/2 times perimeter times the slant height. Which piece over there for the pyramid is the lateral area? The one with the slant height, 1/2 perimeter slant height. That's the lateral area of the pyramid. All right, so looking at this shape, because I've got one on top of the other, there's some pieces of this surface area formula that I don't need because they're no longer on the surface of this object. We've covered them up. Do I need the lateral area for both of these objects? Yes, that's the side pieces. The lateral area would be these walls around the bottom of the object and then those triangles on the pyramid. Do we need all of the bases? I've got 2 bases here and a 3rd base over here. Do I need all 3? How many bases are actually on the surface of this object? Just 1. Is it attached to the pyramid? Nope, so I'm going to get rid of that base. And so over here with my rectangular prism, we only have 1 base that we need the area of. That's just the bottom. And you guys told me over on volume that our base is a square, so this would be side squared plus perimeter of the base times the height, plus, we totally cut out the base altogether over here, so 1/2 perimeter of the base of the pyramid times the slant height. And my sides of my square, the sides of my base are 6, so I have 6 squared for the area of the only base that we've got. Now I need the perimeter of the base. It's a square base, so how do I find the perimeter of this base? 6 times 4, we have 4 sides. Each side is 6 inches, so that means a perimeter of what? 24 inches for my perimeter. So 24 times the height of the prism. What is the height of the prism? 3. Plus 1/2 the perimeter of the base of the pyramid. What's the perimeter of the base of the pyramid? Perimeter of the base of the pyramid, all the way around the base of the pyramid. 24. It's exactly the same as my rectangular prism because the bases on my rectangular prism are congruent and that pyramid is sitting exactly on top of it all. No overhang at all. And then times my slant height. What's my slant height? 5. All right, let's find each of these in turn. 6 squared would be what? 36. So that's the area of the base plus the lateral area of the prism, 24 times 3. You said 72? Awesome. plus 1/2 times 24 times 5, the lateral area of my pyramid, 60. And then we add all of those together, 168. Units? Inches squared. Beautiful. Very, very nice work on the warm-up today. We have one final problem to go over in your notes today. It's similar to the first one that we did yesterday with the 3 golf balls in the sleeve. It's a very similar problem to that. So page 13 in your notes, down at the bottom of the page. Says a soccer ball is usually packaged 1 to a box. So 1 soccer ball per box, and it tells me that my box is a cube shape. What is the volume of unused space inside the box holding this soccer ball if the diameter of the soccer ball is 8.8 inches? Well, very first thing I'm going to do is sketch this out so that I can wrap my head around it. So I'm going to draw the box. All right, so here's my box. Something like this. And we have a soccer ball inside of it. And it doesn't say it, but this soccer ball should fit perfectly inside the box. Similar to number 3 yesterday, the ball should be flush against the sides of the box. So it should just be touching the edges of the box here and here. What do we know about this soccer ball? Diameter is 8.8 inches. So if the diameter of the soccer ball is 8.8 inches, how big is this side of the cube? 8.8 inches. How about my width on the cube? 8.8 inches. And the height on the cube? 8.8 inches. We want to know the volume of unused space. So all we have to do is volume on this problem. So I want the volume of the cube minus the volume of the ball. What shape is a cube? Is it a pyramid? Is it a cylinder? Is it a cone? It's a prism. It's a rectangular prism. And a ball is what shape? That's a sphere. All right, how do I find the volume of this cube, the volume of a prism? Yep, area of the base times the height, minus, how do we find the volume of a ball, of a sphere? 4/3 times pi times the radius cubed. The area of the base of the cube, what shape is the base of the cube? A square. And how do we find the area of a square? Side squared. So side squared times my height. Do we know how big the sides are on this cube? 8.8. So 8.8 squared. What is the height of the cube? 8.8. So 8.8 squared times 8.8, or that would be the same as 8.8 cubed. What do we get for the volume of the box? 681.472. Minus the volume of the sphere, 4/3 pi r cubed. What is the radius here? 4.4. We take our diameter, we cut it in half. Since my diameter is 8.8, my radius will be 4.4 inches. So 4/3 times pi times 4.4 cubed will give me the volume of the sphere. What is the volume of the sphere? 356.817. What came after the 7? A 9, so that's going to round it up to an 8 when we round it out to 3 places, 356.818. If you were to round it to 356.817 on the test, I'm not going to take off any points. So if you're still a little confused about exactly when we round up and when we don't, that's not going to cost you points on the test. All right, so volume of the box, everything that can fit inside the box, minus volume of the ball, because we've got space taken up by that ball, gives us a leftover amount of how much air inside the box. Yes, 324.654 inches cubed. Fantastic. That finishes up the last bit of your notes for 11B. That is the last notes you will take in geometry for the entire year. We have almost 20 minutes left in class. This time is to be spent working on the homework that is due on Monday. This is a very important homework. It brings together all the ideas except for one that we've worked on in Module 11B. We're looking at volume, we're looking at surface area, we're looking at prisms and pyramids, cylinders, cones, and spheres. So all of those ideas. The only thing that's not touched on this homework that's a great initial review for the test is the stuff that we looked at the very beginning of this module about cross-sections and rotations, which we'll review next week when you guys get your actual review packet. But this homework assignment is a really, really good first review for the test.